Good morning to one and all present here. I am Dr. K. REVATHY, Assistant Professor of Chemistry, Sri Sharda College, Pavangan. Today, we are going to see the topic, the most important one nowadays. The green chemistry is the most needed one. Let us see who has coined the term green chemistry, why it is needed, when it is founded, for what we have to do the greener chemical reaction, where we can do that, and how we can do the green chemical reactions. We should know that this man, she is a professor of Gala University, Paul T. Anastas. He is known as father of green chemistry. It is also known as sustainable chemistry, clean chemistry, environmentally benign chemistry, which focuses on the design of the products and process which minimize or eliminates the use of hazardous substances. And why we have to use this green chemical concept, green chemistry concept. Here, in case of conventional procedure, we should work up with many acids or bases to recover the product. But in case of green chemistry, there is no such workup procedure or needed because we are working with the greener solvents only. So that kind of working up procedure, tedious working up procedure is not needed here. And when it is coined, 1998, Sir has coined the term green chemistry. And how we can do the green chemical reaction. In normal laboratories, we can perform the organic conversions by using greener solvents and greener reagents. So for what purpose we have to do? To replace the conventional procedure, tedious conventional procedure, and also to avoid the derivative steps and improve the yield. So we have to go for the greener chemical reactions. And this is the definition of green chemistry. The green chemistry means it is a design of chemical products or process that minimizes or eliminate the use or generation of hazardous substances. The hazardous means it should not be hazardous not only to human but also to animals, plants, and the environments. The objective of this green chemistry is to find out the greener chemical approach than the existing less acceptable one, and also to lead a sustainable development. It means the development should meet the need of the present without compromising the ability of future generations to meet their needs. The goal of this green chemistry is to design or redesign of products and manufacturing process to reduce the impact of human health and the environment. It leads to the idea of sustainability, that is, reducing environmental impacts and conserving natural resources for future generations. Here we should know some green chemistry terminologies, which are atom economy or atom efficiency. The atom economy means the utilization of atoms from the reactant 100%. It should be 100%. That is 100% of atom. That is all the atoms of the reactant should be converted into a product. So that is the measure of atom economy. it can be said in the form of ratio of mass of the desired product to the total mass of the product, which is nothing but the percentage of the atom economy. This is the first concept. It is known as atom economy or atom efficiency, AE. And then the environment factor. It is a measure of how much waste products are produced per unit mass of the desired product formation. That is, mass of the actual waste product divided by the mass of the desired product. It gives the environmental factor, E factor. And then the another term is environment quotient. The environmental effect of waste of a chemical reaction, it does not depend not only on its amount, but also on its nature. For example, a waste material from a reaction is sodium chloride. If you're obtaining the sodium chloride as a waste material, its amount is 1 kg. So 1 kg amount of sodium chloride is nothing but not that much waste. But in case of quantity, if the reaction provides 1 ton of sodium chloride as a waste material, the disposal of that sodium chloride is a little bit difficult task. So it does not depend not only on the amount, but also in its nature also. Here, we are going to see the principles of green chemistry. The first one is waste prevention. The waste prevention is better to prevent the waste that is generated rather than to treat or clean up the waste after it has been created. And the second one is atom economy. Just now we had seen the concept atom economy, that is 100% utilization of atoms from the product for the formation of the products. That is, the synthetic method should be designed to maximize the incorporation of all the materials used in the process for the formation of the final product. And the next one is less hazardous chemical synthesis. Whether practicable, synthetic methods should be designed to use and generate substances which possess little toxicity or no toxicity to human health and also to the environment. The next thing is designing safer chemicals. Chemical products should be designed to affect their desired function while minimizing the toxicity. And then safer solvents and auxiliaries. The use of solvents should not be toxic to the environment. That is, the use of auxiliary substances, that is solvent, separating agent, should be made unnecessary whenever possible and innocuous when used. That is, the greener solvents should be used here. The design for the energy efficiency. The energy required for an organic conversion, for a chemical conversion, it should be recognized for the environmental and economic impact. It should be minimized. If possible, synthetic methods should be conducted at the ambient temperature and pressure. For example, the reactions can be carried out by using the enzymes. Like that, we can energy efficiency reactions also be planned out. And the use of the renewable feedstock, the raw material for the conversions or feedstock, it should be renewable rather than the depleting whenever technically and economically practicable. That is bio-based solvents and reduced derivatives. Unnecessary derivatization, that is the use of blocking groups, protection, and then followed by deprotection, temporary modification of physical and chemical process. And these derivatizing steps should be minimized or avoided if possible, because these such steps require additional reagents and it can generate waste also. And then the catalysis. The catalytic reagents are superior to the stoichiometric reagents. So in some cases, we can use transition metal catalyst. These metal catalysts can be used in the catalytic amount and then it can be recovered after the reaction also, and it is reused for the further reactions also. And then the design for degradation. The chemical product should be designed so that at the end of their function, it should get breakdown into the innocuous degradation products, and it should not persist in the environment. The next principle is real-time pollution prevention. The analytical methodology is needed to be further developed to allow the real-time, that is in-process monitoring and control prior to the formation of the hazardous substances. The last principle is safer chemistry for accident prevention. The substances and the form of substance used in a chemical process should be chosen to minimize the potential for chemical accident, including releases, explosions, and fires, etc. These are all about the principles of green chemistry. Let us see the alternative energy sources for performing the chemical reaction. There are so many alternative energy sources. Few are listed here. Number one is microwave, ultrasound, mechanical energy, water mediated reactions. This water also can be used as an alternative source for the reaction medium, ionic liquid, supercritical carbon dioxide, deep eutectic solvents, enzymatic reactions, etc. So among these alternative energy sources, here we are going to see the microwave energy as an alternative source for performing the most of the organic conversions. Let us see how the microwaves are used as a radiation for energy conversion. These microwaves are found to be in the range of zero point 0.3 to 300 gigahertz, which lies in the electromagnetic radiation spectrum between the radio wave and IF frequencies, with relatively larger wavelength and in the form of energy, not in the form of heat, and also invisible non-ionizing radiations. From the name itself, we came to understand that it is non-ionizing, that is, it is not able to ionize the molecular atom, but surprisingly, it enhances the reaction rate when the microwave is used rather than the conventional heating. And the advantages of using this microwave radiations are the reaction time is reduced in compared to the classical procedure, and the yield is improved with the less or very less side product. Solvent-free reactions also can be performed. Cleaner reactions with the easy workup procedure, and the reaction efficiency is also increased. How it interact with the molecule? So the microwaves couples directly with the molecules in the reaction mixture with rapid rise in temperature by means of temperature, increase in temperature, dipolar rotation, ionic conduction. And these are all the two most important fundamental mechanisms for the transfer of energy from microwaves to the molecules which are being heated. Then we are going to see about the generation of microwave. The generation of microwave is through by means of the magnetron. Here in the picture, it shows that the magnetron concept. Here at the center, the A represents the solid metal cathode and the B represents the anode. When the cathode is heated, the energized electron from the cathode is liberated and gets circulated around the cathode, which is in between the cathode and anode. Because of the presence of magnetic field in between the A and B, that is cathode and anode, because of that magnetic field, the electrons get circulated around the cathode. When it enters into the anode having these resonant cavities, the cavities get resonated, and it emits the microwave radiation in the form of energy. So this microwave energy can be used as an energy source for organic conversions. I will repeat it again. Here, the microwave can be generated by using the concept magnetron. It consists of cathode A and the anode B. The cathode A is a solid metal. On heating this solid metal A, it it produces electrons which get circulated around the cathode. Why it gets circulated means because of the presence of the induced magnetic field around the cathode. That is, in between the cathode and anode, there is the presence of the magnetic field. Because of that magnetic field, the liberated electron get circulated around the cathode. If while circulating, if it enters into the resonant cavity of the anode, this resonant cavity get vibrated, get resonate, and this resonance get in the form of microwave irradiation. And let's come the differences between the microwave and conventional heating. So the rate of heating is found to be fast in case of microwave and slow in case of conventional. Selective absorption by polar component in case of microwave, but it is non-selective for conventional. How it get interacted with the molecules? In microwave, it get coupled at the molecular level, but in case of conventional, outer surface is heated at first and then the molecule get heated. The mode of heating is simultaneous heating of the whole material in case of microwave, and here it is the heat is introduced from the outer surface of the vessel. The process is found to be energetic coupling in case of microwave, and it is conduction or convection in case of conventional heating. Here are some examples. Hereafter, we are going to see about the organic conversions which are induced by the microwave irradiations. These are all the coupling reactions, example of coupling reaction. Generally, these coupling reactions can be catalyzed by using the palladium salts, which are very highly cost effective. So while using microwave irradiation and some reusable and environment safer catalysts like TBAB, that is tetrabutyl ammonium bromide, we can perform the Suzuki reaction, that is the reaction of boronic acid with aryl bromide in presence of potassium salt, phosphorus sulfate, potassium phosphate, and tetrabutyl ammonium bromide. Upon microwave irradiation, it gets converted into the biaryl compound. Similarly, we can perform the Sonogashira coupling. The aryl bromide, reaction of aryl bromide with the phenylacetylene in presence of tetrabutyl ammonium bromide, sodium carbonate under microwave irradiation, it gives a substituted phenylacetylene. And then comes a HIAMA cross coupling. Aryl halides with the silyl enol ether in presence of palladium acetate salt in presence of tetrabutyl ammonium bromide and sodium hydroxide under microwave irradiation, it gives a substituted alkenes. And then comes the Rutter reaction. That is a reaction of aryl cyanide with the alcohols in presence of Nafion membrane under microwave irradiation. It gives a substituted amides. And then let us see about the microwave-induced rearrangement reactions. Here comes the Beckmann rearrangement. In general, Beckmann rearrangement, the reagent, the group which are anti to the OH get migrated here. In presence of montmorillonite K10 under microwave irradiation, it provides substituted amides. Similarly, in case of benzylic acid, the benzyl is converted into benzylic acid by using silite as a clay in presence of potassium hydroxide, water, and microwave irradiation. The another example is pinacol rearrangement. This pinacol, this diol is getting converted into the pinacolon ketone by using the metal incorporated montmorillonite and a microwave irradiation for 15 minutes. It gets the maximum conversion of the products. Here comes the examples for oxidation, reduction, and hydrolysis. In general, we know that the oxidation of primary alcohol lead to the formation of the aldehyde, and on further it gets oxidized to the acids. Here, the primary alcohol is oxidized by using the tungstate salt. Under microwave irradiation, it gets converted into the acid. Similarly, oxidation of the aromatic side chains, that is the toluene, by using potassium permanganate and potassium hydroxide under microwave irradiation, it gives benzoic acid as a product within short time of duration, that is only 5 minutes. The same conversion can also be carried out by using the vanadium pentoxide and titanium dioxide as a catalyst or a microwave radiation. It gives the benzoic acid as a product. The another example is the reduction. That is the reduction of aldehyde, it gives primary alcohol. In case of ketone reduction, it gives the secondary alcohol. This ketone, that is the acetophenone on reduction with the sodium borohydride and alumina, upon microwave radiation, it gives the secondary alcohol. And then this is the hydrolysis reaction. In organic practical, we can do this reactions, that is the hydrolysis of ester and the aromatic amide by using the aqueous sodium hydroxide solution. After that reaction completion, we have to work up with the concentrated HCl, then only we will be getting the acid as a product. Here, we are using aqueous solution of sodium hydroxide under microwave radiation. Within just 2.5 minutes, it gets converted into, that is, the ester group get hydrolyzed to the acid. Similarly, the aromatic amide is also get hydrolyzed to the corresponding acid within 7 minutes of microwave irradiation. Here comes the microwave assisted synthesis of heterocyclic compound. Only we are going to do examples here, Bigelow reaction and Manich reaction. Bigelow reaction means the conversion, that is the reaction of dicarbonyl compound, the aldehyde and urea or thiourea in presence of PSSA, polystyrene supported sulfonic acid under microwave radiation. It gives the formation of the pyridine derivatives. Similarly, the reaction of benzaldehyde with melanonitrile in presence of substituted ferrocene ketone and ammonium acetate as a nitrogen source, upon microwave radiation, it gives a pyridine derivative. Managed reaction. And reaction of aldehyde with acetylene and in presence of the secondary amine and copper plus bromide, under the irradiation of microwave, it gives a substituted alkynes as a product. So as of now, we had seen that what is the need of green chemistry, what is green chemistry, why we have to do, where we can do, how we can do. So all those things we had seen, and we had seen the father of chemistry or father of green chemistry also. And after that, we had seen alternative energy sources for the green chemistry. We had seen the green chemistry principles, 12 principles also. We had seen the alternative energy sources for performing the chemical reactions. Among that, we had seen the micro-assisted synthesis for various conversions with the help of microwave. So with this, we are winding up the session. And in the upcoming session, we will be having ultrasound irradiated organic conversions and the synthesis of heterocyclic compounds. Hope the session would be helpful to you. Any queries, please text me. Thank you.